It's back. Sure you remember this from my past video, but this is my 3018 CNC router. And before all you software guys go running away in fear of touching real, actual hardware, today's mostly about software. So in the past video, I used my laptop and I plugged it directly into the router, and I had my laptop send G-code to the router. And that worked. It was just kind of a pain because my laptop was stuck sitting here and I can't go do other things while I kind of babysit the router. And so I want to improve my workflow a bit here. So I got some things to help out with that. Got a Dell Wyse 3040 thin client. These are available on eBay for like 30 bucks, maybe 40 if you want a power supply. And because Raspberry Pis are basically unobtainium right now, this is going to stand in for a Raspberry Pi. And it's going to sit somewhere on the router and plug into the router's USB port, and it's going to run a web interface to let me control the router, send G-code, all the stuff I did in the last episode, but without tying up my laptop in the process. And as a bonus, I bought it a webcam too, its very own webcam, so I can sit here and watch it like a baby monitor. So we're going to take the router and the thin client and the camera, and we're going to get this all working in a nice cohesive setup where we can run the CNC from a web interface from anywhere. In theory, you should obviously stay in the same room as the router while you're using it. We can look at the router on the webcam in case we didn't stay in the same room with it. And we can record the router from the webcam so we can make beautiful YouTube videos of all of our creations later. Because everyone knows it didn't really happen if it wasn't on the internet, right? So here's the software we want to install. It's called CNCjs, and it's written in Node.js, and it's basically a web GUI for CNC routers that have their own motion control firmware already. Either grbl or SmoothieWare, most common. So up at the top here it says the easy way to install it is by using npm install CNCjs. So npm is the Node.js package manager, so in order for us to install CNCjs, we first need to install Node.js and npm. Hopping over here to SSH, I've already installed a bare Ubuntu Linux 22 Jammy Jellyfish install. This is Ubuntu server with nothing installed except OpenSSH. So this is bare as it gets. So we need to sudo apt install Node.js and npm, which is the Node package manager. Looks like we're installing a whole lot of stuff today. So now we can run npm. We're going to run it as sudo. So because we're running as sudo, we have to say unsafe permissions. Okay, so it seems like it's looking for some really old versions of some packages, which is unfortunate, but we're going to go anyway. So in theory, we should be able to run CNCjs now. Just CNC, let's try help. So just as a test, let's launch it and see if we can get to it from web browser. So we'll set it to port 8080 for now and allow remote access. So here we go. We got webcam is off. We got everything here. It's working. At least it appears to be. So now let's make this start automatically. So when we ran it, it created a new file called .cncrc. So let's see what it put in it. So we can add a few lines here if we'd like, such as allow remote access true. Up until this point, we've been testing CNCjs using port 8080, and we actually want to turn on port 80, which is the standard port. But Linux doesn't allow normal programs to run on port 80 unless they have sudo permissions. So we could run the binary as sudo, but that's a bit more complicated. So what we want to do is give permission to CNCjs to bind to low-numbered ports without giving it full admin permissions. So we can use the set cap capability, so sudo set cap net bind service equals plus VIP, and we want to give that to the CNCjs binary, which is a little bit deceptive because the binary to actually run that is node.js. So we actually need to give that permission to user bin node. So we need to give it the path to the executable that we're going to give this permission to. So now we should be able to run CNCjs as P80. It should come up and be able to run without sudo on port 80. So there we go. We were successful in starting the server. So that means we can use this here, CNCjs-P80, and it should automatically load the config from our home directory. And we want to create a service file to run this as our local user, which in this case I named Discovery. So now we need to create the systemd service file. And you can copy and paste it from my website. So first we're going to create the file by touching it. So etc systemd system CNCjs service. And then we need to give it permission 664. And then we edit it. And you can copy and paste the contents of this from my website. So here's basically what I've done. So in the description, I called it a CNC controller web UI. And we want to run it after network online. So once the network is finished initializing, then it will run CNCjs. Our command is CNCjs port 80. We're going to run it as user discovery. So instead of as root, we're going to run it as our local user discovery. We're going to run it in Discovery's home directory, home discovery, and we will restart. So let's save that. Now we need to run daemon reload. So system control daemon reload. And then we can start the service. And if we want it to start on boot, we enable it. And then to see the logs, we can run sudo system control status. So I flip over to the web browser. So now we're not passing a port, we're just running as port 80. And we can reload and see. So CNCjs comes up on port 80 just as we want. We're not running it as admin, we just gave it permissions to bind to a lower port. And I don't actually have the router connected up here, so it won't find anything. Now we can try it out with the router. It's possible you get an error opening the serial port, and this depends on how your operating system's configured. If you're on a Raspberry Pi, you probably won't have this problem. On Ubuntu, by default, users don't have access to the dial-out group, which means they can't use serial ports. So if I look at what groups I'm a member of, none of these say dial-out. And in order to use TTY USB 0, we need to either be root or a member of the group dial-out. So what we can do is sudo usermod -a big G, and then the name of the group, and then the name of the user, which in my case is called Discovery. Done. And then of course restart CNCjs. So now we're connected. The machine is e-stopped though, so it's not going to do much. So let's go on to the webcam now. We're going to use mjpeg-streamer to set up an HTTP stream so we can view the webcam. So this package is not in apt on Ubuntu, so we are going to install it from source. And I have the commands for this on the website. So first we need to install some dependencies. So cmake and libjpeg8dev. So now that we've installed the dependencies, we can clone the Git repository. And we can cd into it. For some reason, the mjpeg-streamer guys put their code in a subfolder called mjpeg-streamer experimental. And then we run make. And we wait. Okay, it says it's done. So now we're going to sudo make install. Well, it says it did it. So we're going to run mjpeg-streamer. We're going to use an input. And we would like to use input UVC. And device. If you have more than one webcam, you can create more than one instance of mjpeg-streamer and pass a different device to each one. I only have one webcam, so in this case it's video 0. You can technically leave out the device and it'll use the first one it finds. I'm going to give it port 8080. Again, if you have more than one webcam, you'll want to use different ports for each one. Error opening. Oh yeah, we don't have permission. Because we need to be a member of the video group, or we need to use sudo. Okay, so it started. So it defaulted to 640 by 480, which is not great. It's using -1 frames per second, which means letting the camera decide. It's using camera-based JPEG, and it says inappropriate I/O control, so it can't do pan tilt, which is fine. We didn't expect it to. So you can see how I went to port 8080 /?action equals stream. And I got the camera, but it's only at 640 by 480. And it's also got this rolling shutter artifact, because for some reason the camera defaulted to 50 Hertz, which is European. Let's try some more arguments to the input codec. So we're going to use our resolution, 1920 by 1080. That should be the maximum our camera supports. We're not going to give it a frames per second because we're going to let the camera decide. And I want to set power line frequency. No, that's not the best. I guess we'll be stuck with the rolling lighting effect. So you can clearly see the artifact in between the 60 Hertz lighting and the 50 Hertz noise rejection. But it's working. So now that we've figured out how to run the streamer, let's turn it into a service again. So just like we did before, we're going to create a systemd unit file, and we're going to edit it. So again, I have the commands for this on my website. I'm going to call this one webcamd. You can call it whatever you want. So I'll paste in those commands. And now we got a new service. This one's pretty simple too. So we're going to call this one webcam stream. We're executing mjpeg-streamer on dev video 0, resolution 1920 by 1080, outputting on port 8080. Then we'll start the service, enable the service, and it should come up in the usual place. Sure enough, we got a nice stream here over the web browser. Now the camera stream is working, we can add it to CNCjs, and we can do that through the web interface. Turn off the widgets I don't need. I don't have a laser. So let's edit the webcam widget. And we're going to use an IP camera. And here is where you would put in the IP address of your, whatever you're hosting CNCjs on, or the DNS address if it can resolve. We're running it on port 8080 and we want to stream it. That's the same command we passed in the web browser, but we're adding it to CNCjs. So now if I click here, webcam is on. I could rotate it, but that doesn't seem like the best move, but it works. We got crosshair. I don't know why we need a crosshair in this particular view, because we don't have the spindle or anything in view, but it's there, it's available to us. You can bring the webcam full screen from within CNCjs, which is nice. Or we could exit it. So that's working, that's nice. So now we don't have to care about this running on port 8080 anymore, because CNCjs will deal with that for us. Now we should be able to use ffmpeg. Sure looks like ffmpeg worked. Give us some options. So let's record our local stream to a file in our new directory. So our input is going to be http localhost 8080 action stream. We don't want to transcode. By default, ffmpeg will infer what codec it should use from your file extension. And we're going to use mjpeg, but we don't want it to transcode mjpeg. So we're going to say codec copy, which means just copy the input to the output with no modification. So in this case, it will unbundle the input, but keep the video frames as they are without transcoding them. So our new file could have a different container format, but it's going to copy the raw video information. And our output is mount CNC, we'll call it test1.m mjpeg. So there we go, it's doing a thing. Let's see if we got a file there. And we sure did. So if I open that file, test1.mjpeg, it looks pretty boring. So now we need a script to start the ffmpeg recording. So we're going to create one. Rec start. Copy the code from the blog, as one does. So basically the file name includes the date, hour, minute, second. And I also added on the end here no stats. That way we don't have to deal with ffmpeg pushing a bunch of stuff. So then we need to make it executable. And we can run it. So ffmpeg is printing stuff to the screen, but we can still use the terminal here. So then to stop it, we say kill all ffmpeg. Again, stops. So our stop script is just going to call kill all. Pretty simple. So now we should be able to use these scripts from CNCjs. So over here, we're going to call start. So when G-code starts, we're going to run rec start. And when G-code stops, we're going to run rec stop. I think it wants these to be given full paths instead of partial paths. Or maybe it's not expanding them. So we'll copy the full path. We'll create a command and we'll create an event. Okay, so does that work now? Start record. Oh yeah, now we're recording. So actually we'll go back over here and say command stop record. And we should have a file. Okay, we are ready to test this, so let us hit the YOLO button. YOLO. So finally, I've freed my laptop from the tethers of this machine. I can watch it beautifully from the beautiful webcam that doesn't have a mount yet. And the machine can make a mess while I sit comfortably away, close enough to hit the E-stop if it does something stupid, and far enough away that I can get work done. As always, don't forget to like and subscribe. There's a link to my Discord down below if you're into this kind of stuff. And stay tuned for the next adventure.